At 100 million years after the Big Bang, gravity began to ignite the cosmic night. Gas in vast clouds collapsed under its own weight, and the first population 3 stars flared to life. These primordial suns, made almost entirely of hydrogen and helium, set off fireworks of light that pierced the cosmic darkness. In the blink of a galactic eye, they ended the universe's dark ages, breaking apart neutral hydrogen with their fierce ultraviolet glow. The universe had switched on the lights, forever changing the fate of everything that followed. Billions of these newborn stars were swept together by gravity into roiling proto-galaxies, each a brilliant city of light. Imagine vast rivers of gas and dust tracing out an immense network. The cosmic web, hundreds of millions of light years across. Along its filaments, galaxy clusters would form, congregating thousands of stars per cluster and spanning tens of millions of light years. Invisible dark matter ruled this dance. Each galaxy sits in a halo weighing as much as 1 trillion suns, and it is the gravity of this dark scaffolding that guides young galaxies into ever larger structures. Gravity's web grows, and with it our wonder. How did the universe stitch itself into this grand design?
Across the cosmic web, mystery abounds. Billions of years will pass before we fully unravel this tapestry. But already we see hints. Filaments stretching 100 million light years long, and cosmic voids hundreds of millions across. Where filaments cross, galaxy clusters form, the universe's cities, each with hundreds of galaxies bound tight by gravity. Every supercluster, every galactic node, marks a story of matter pulled from emptiness. We on a pale blue dot are riding one thread of this web. Even as starlight travels 110 million light years, it shows us images from the age of dinosaurs. It's humbling. Looking out of the web is like looking back in time and seeing how destiny was woven. And it begs the question, what powerful forces are at work behind the curtain? By 3 billion years after the Big Bang, the universe reached its cosmic noon. Galaxies swelled, forming stars tens of times faster than today, reaching a fever pitch of creation. In a few billion years, most of all stars that will ever shine were born, lighting up the heavens for eons to come. Pause on those numbers. Billions of stars, each a furnace of nuclear fusion. Trillions of planets, each orbiting a sun as we orbit ours. We are minuscule, but intimately connected to this grandeur. Every atom in your body was forged in long-dead stars. Every photon reaching you traveled across cosmic history. In the faces of these distant galaxies, we see echoes of our own origin. An existential thread from the Big Bang to the beating heart of our civilizations.
Yet gravity has a dark side. The same force that built the stars can ruin them. Massive stars end their lives catastrophically. Their cores collapse, and for many, a black hole is born. These black holes feed on nearby gas and even stars. Supermassive black holes, weighing millions of billions of solar masses, lurk at most galaxy centers, becoming grim engines of destruction. Around them swirl disks of gas accelerated to near light speed, forming twin jets that shoot vast plumes thousands of light years into space. Imagine that terror. A star wandering too close is spaghettified, tore apart by tidal gravity. In a brilliant instant, the star's gas is ripped out and some fuels a violent flash that can outshine an entire galaxy for a moment. These titanic events teach us the very forces that bring stars alive can also unmake them in bursts of radiation and energy that redefine their worlds. But in destruction lies creation. Only a rare fraction of stars, those over about 8 times the sun's mass, explode as supernovae. Their death throes are the universe's forge, building and spewing heavy elements into space. In a searing, expanding shockwave, a supernova synthesizes elements from carbon and oxygen up through nickel and iron. The result: vast clouds enriched with every atom needed for planets and life. These shockwaves also sweep up gas, compressing nearby clouds and triggering fresh star birth. From the ashes and shock fronts, new suns ignite, and planets coalesce from dust. This cosmic cycle, death-seeding life, is astonishing. The atoms in Earth's oceans, in your body, in every world, were once nestled in these stellar graves. The horror of stellar death gives way to the promise of rebirth.
From these enriched clouds, our own sun was born. A nearby supernova likely triggered the collapse of a nebula that became the solar system. Around 4.5 billion years ago, gravity pulled the gas and dust into a spinning disk. In its center, our sun ignited. Beyond, planets formed from the remaining material. Earth emerged battered by asteroids, a molten orb shrouded in toxic gases and acid rains. In those hellish early days, when the surface was uninhabitable, only oceans remained calm. Yet even there, miracles occurred. Cracks in the ocean floor, hydrothermal vents, spewed minerals and heat into the dark sea. Rich in hydrogen, methane, and other chemicals, these vents may have been the cradle of life. Their chemistry could drive early metabolism. Tiny microbes like acetogens and methanogens thrive today on just these ingredients, suggesting life's first cells may have done the same. Deep below, in those black, high-pressure waters, chemistry ran wild. Heat from the vents powered reactions that slowly built the first cell membranes and biomolecules. Chemosynthetic microbes evolved to harness this energy, forming entire ecosystems independent of sunlight. In this lightless world, life found a way. Over 3 billion years, single-celled organisms ruled the Earth alone. It was a microbial empire invisible to the eye. But even tiny life is transformative. Around 2.7 billion years ago, cyanobacteria began using water to photosynthesize. Oxygen was released as waste, and for the first time free O2 started to accumulate in oceans. Slowly, over hundreds of millions of years, this oxygen overcame sinks in rock and methane.
Eventually, Earth's atmosphere changed forever. Between 2.4 and 2.1 billion years ago, enough oxygen had built up to trigger the Great Oxidation Event. Methane, the powerful greenhouse gas, was replaced by oxygen. The planet cooled into a deep global ice age. Nearly all life then was anaerobic, and this oxygen surge proved toxic to many species, causing a massive die-off. But from this crisis arose opportunity. Oxygen respiration evolved, delivering far more energy for each cell than before. Life found more power in metabolism, and complexity began to increase. After another billion years of twilight life, organisms started banding together. Some cells merged or formed colonies, experimenting with multicellularity. As the final Neo-Proterozoic Ice Age ended, 600 million years ago, life exploded onto the scene in myriad forms. The Cambrian explosion lit up the fossil record around 540 million years ago. Eyes, shells, and spines in countless shapes, ancestors of all animals alive today. And life continues to rush forward, from those first vents of forests to consciousness pondering the cosmos. In every stage, from dark, starless void to vibrant living world, a single truth repeats. Gravity and chemistry, over unimaginably long times, build complexity from chaos. And through it all, the story comes full circle. 100 million years after Big Bang, the age of stars begins, and will begin again